Okay, dear subscribers, welcome back again, solving numerical problems from Engineering Mechanics by Professor Timoshenko, Professor D.H. Young from Stanford University, and two more famous people, Director J.B. Rao, Professor Pati from India. And this is a classic, these solutions are from a classic book, textbook, which has been much praised and used by teachers and students for almost 80 years now. Now problem set 2.6 solution to 2.97. Let me read out the problem first. 2.97, a prismatic bar from here to here, AB is a prismatic bar. This was the initial position. AB was the initial position of this prismatic bar. It was when it was horizontal. A prismatic bar AB of weight P. The weight is acting vertically downward from the center of mass or center of gravity. When this prismatic bar was horizontal, this angle alpha was 90 degree, and this end of the prismatic bar, the end B, is attached with a spring, and the spring is connected at C. And the prismatic bar is capable of turning about the point A. Why it will turn about the point A? The weight of the prismatic bar P, which is acting vertically downward, from this point, the line of action of P has a perpendicular distance. So it will rotate the prismatic bar clockwise. So once it is rotated, the spring which is attached to the end B will be stretched. So there will be restoring force. The spring will try to regain its original configuration due to the restoring force, and the restoring force will be acting along the spring to this side. So in equilibrium, we'll find out how much is this force. Then we'll find out the component of that force along this direction and along this direction. And the component of that restoring force, which is along this direction, will have some perpendicular distance from A, that is the length of the prismatic bar L. So it will try to rotate it anticlockwise. So there will be two forces, the effect of P about this point and the effect of the restoring force about this point, means the turning effect. If both are equal and opposite, it will be in equilibrium. So that is the basic understanding. So let me read out and then proceed. A prismatic bar AB of weight P is hinged at point A and attached to a spring at point B. This end of the prismatic bar is attached to a spring. The stiffness of a spring is K and the spring is undeformed when alpha is 90. Means when this prismatic bar was horizontal, then this angle, this alpha was 90 degree. Find angle alpha corresponding to the equilibrium in terms of the weight of the prismatic bar P, the spring constant K, and L, the length of the prismatic bar. Now from this point to this point is also given as L. So what I just explained to you, that is what I have done here. So the bar AB is capable of turning about point A due to its weight P. When this alpha is 90 degree, AB was horizontal. This is the position, was horizontal. Means the spring was not stretched. So from this point to this point is L, from this point to this point is also L. So from point C to point B is the length of the spring when it was not deformed. So what will be the length of the spring from here to here when it was not deformed will be L square plus square root of that. So Therefore, the undeformed length of the spring is equal to L square plus L square root of that is equal to root times L. From here to here is L, from here to here is L. So this angle is 90. So CB is the hypotenuse. So it will be root 2 times L. So CB is your root 2 times L. That is the situation when the spring has not been stretched. It has not been deformed. Now, now I have drawn another diagram for you. The situation when the spring is stretched means the new position of the spring is from C to B dash. That is what I have shown here, from C to B dash. From C to B dash is the new position of the spring when it has been stretched due to because the prismatic bar has turned about the point A due to the load P. So now from point A, same thing as this point A, I draw a perpendicular to C B dash. Therefore, D is the midpoint of C B dash. Let from C to D is equal to from D to B dash equal to X. Because D is the midpoint, this angle is 90 degree here. So the new length of the spring in the deformed position is from C to B dash will be from here to here is X, from here to here is X. So X plus X, that is equal to 2X. Now in triangle ADB dash, AB dash is equal to length of the prismatic bar. Now, since this is the midpoint, this is the perpendicular, and this angle from here to here in the different position is given as alpha. So this perpendicular bisector AD will divide this angle alpha into two equal parts. So from here to here will be alpha by 2. From here to this angle will also be alpha by 2. So in triangle ADB dash, this is alpha by 2, this is 90. So the remaining angle, so this has to be 90 minus alpha by 2. So now if you take cos of 90 minus alpha by 2 will be base over hypotenuse, that is dB dash over the hypotenuse AB dash, that is equal to dB dash over L. So if you cross multiply, you get so your dB dash, which I have taken it as X, is equal to L times cos of 90 minus alpha, that is sin alpha. So from this point to this point, the length is X is equal to L times sin alpha by 2. So the length from C to D will also be L times sin alpha by 2. So the 2X, the new length of the spring in the deformed position will be 2 times this, 2L sin alpha by 2. Let it be equation 2. Let it be equation 2. Now, so we know the previous length of the spring in equation 1, root 2 times L. And this is the new length of the spring when it is in the deformed position. So then by what amount the spring has been stretched? Therefore, the spring is stretched by CB dash minus CB. So the spring is stretched by CB dash minus CB. CB dash we just calculated, CB we had already calculated in equation 1. So the spring is stretched by CB dash minus CB, that is 2X minus root 2 times L. Now 2X I just calculated, 2L sin alpha by 2 minus root 2 times L. So this is the amount by which the spring has been stretched. And as you know, in your school days or in your college days, when a spring is stretched, there is a restoring force F is given as minus ky. This negative sign only indicates F and y are opposite to each other. Means more is the value of y, more is the F. If you stretch a spring more, the restoring force developed will be more, k being a constant for that particular spring. So in this case, it has been stretched by this amount. So this is equal to your y. So put it here. So F becomes minus k 2L sine alpha by 2 minus root 2 times L. Now what will be the direction of this F? This F, the restoring force, will be directed to this side along the length of the spring. So now we have to find components. A component of this force F, that is F sine 90 minus alpha by 2. Let me show it here again. Now, show it here again. This is the direction of F. One component will be this and one component will be to this side. I am not interested in this component because this component is passing through the point A, about which I will be finding the turning effect. This component does not have any perpendicular distance from point A, so this will not contribute any turning effect about A. But this component will be, which will be F times sine 90 minus alpha by 2, that is equal to F times cos alpha by 2, will have this perpendicular distance from here to here. So this force, which is a component of F, will will have a turning effect about point A. And how much will be that? This force into this perpendicular distance. This is the perpendicular distance from the line of action of this force. So that is what I am explaining here. A component of this F, that is F sine 90 minus alpha by 2, that is F cos alpha by 2, has a perpendicular distance from point A. So it will produce a turning effect. Let that turning effect is represented as tau 1. So that will be F cos alpha over 2 times the perpendicular distance. Now this perpendicular distance, let me put it as b dash. Now, so that is equal to the length of the prismatic bar. So this force into this perpendicular distance will have this force and this perpendicular distance AB dash, which is the length of the prismatic bar. Due to that, it will try to turn anticlockwise about point A. So this will provide an anticlockwise movement about the point A. The line of action of P also has a perpendicular distance from A, that is L by 2 sine alpha. Let me explain how it is L by 2 sine alpha. How it is L by 2 sine alpha. In triangle AGB, look, in triangle AGE, in triangle AGE, this point is taken as E. In triangle AGE, angle GA is 180 minus alpha. Angle GAE means this angle is 180 minus alpha. How? This is a straight line. So this total angle is 180. Alpha by 2 plus alpha by 2 is alpha. So 180 minus alpha is this angle. So angle GAB is 180 minus alpha. GAE, this angle is 180 minus alpha. This is your 90. So this will be, so when this one added to this plus this, it will be 180. So 180, so let this angle is alpha, theta, let this angle is theta. So 180 minus alpha plus 90 plus theta is equal to 180 degree. So 180 minus alpha plus 90 plus theta is 180 degree. 180 cancels, so theta is equal to alpha minus 90 degree. So theta is equal to alpha minus 90 degree. Now, therefore, cos of alpha minus 90, because I am interested to find out the perpendicular distance. So cos alpha minus 90 that is cos of this angle theta I just calculated as alpha minus 90. This I calculated as alpha minus 90. So cos of this angle will be GE over the hypotenuse AE. So cos alpha minus 90 will be G over the hypotenuse. Now the hypotenuse, that is from A to E, this point is the midpoint. So from here to here will be L by 2. So L by 2, so 2 comes here, 2 GE over L. Therefore GE, that is same thing as AH, that is GE is same thing as AH, let this point is H, will be equal to cross multiplying L times cos alpha minus 90 over 2. Now here is something interesting. Now here is something interesting. To make it 90 minus alpha, I take minus common. And we know cos of minus theta is cos theta. So cos of minus 90 minus alpha will be same thing as cos 90 minus alpha. And cos 90 minus alpha is same thing as sin alpha. So L by 2 sin alpha. So this GE or AH is equal to L by 2 sin alpha. Now that is the perpendicular distance of the line of action of P from the point A. This is the line of action of a P from the point A. It has a perpendicular distance AH. AH is same thing as GE. So the perpendicular distance is found out. Now, so it will produce a turning effect. So the clockwise turning effect due to P will be P times the perpendicular distance. This is the perpendicular distance of the line of action of a P from the point A. Now for equilibrium, both have to be equal. So P times L by 2 sin alpha must be F times cos alpha by times AB. And now it is simple. Now put the value of F, which I just calculated, and cos alpha by 2, AB is equal to L. So L will be multiplied here, L will be multiplied here, so it becomes KL square to 2 sin alpha by 2 cos alpha by 2 minus root 2 K L square times cos alpha by 2. So this becomes, now look at this part, 2 sin theta cos theta formula. So KL square sine of 2 theta, sine of 2 alpha by 2. So 2 cancels, so minus root 2 KL square cos alpha by 2. So KL square sin alpha minus root 2 KL square cos alpha by 2 is this much. Now I am interested to finding alpha. So somehow I have to make some modifications. P remains as P L by 2 L by 2. Sin alpha can be written as sine of 2 alpha by 2. 2 cancel, same thing as sin alpha. Then this comes under a formula 2 times sin theta plus cos theta, PL by 2, 2 times sin alpha by 2, cos alpha by 2. This 2 cancels with this. On the right hand side I am left with KL square sin alpha minus KL square root 2 cos alpha by 2. Now if you look, PL sin alpha by 2 cos alpha by 2 KL square, now let me change it again to sin alpha is equal to sin 2 times alpha by 2, that is equal to 2 sin alpha by 2 cos alpha by 2 minus KL square root 2 times cos alpha by 2. By doing so, what do I get? I take cos alpha by 2, I keep this term PL sin alpha by 2 cos alpha by 2 on this side. Here there is cos alpha by 2, here there is cos alpha by 2. These are two different terms, so I can take cos alpha by 2 common. So by taking cos alpha by 2 common, By taking cos alpha by 2 common, I am left to on the right hand side KL square 2 sin alpha by 2 minus KL square root 2. Now this cos alpha by 2 is gone because multiplied on either side. So PL sin alpha by 2 is KL square 2 sin alpha by 2 minus this. Here is sin alpha by 2, sin alpha by 2. I keep them on one side and take sin alpha by 2 common. So I am left with 2 KL square minus PL, and this comes to the left hand side KL square root 2. So now this is multiplied here, it can come to this side, so it is divided. So root 2 KL square over 2 KL square minus PL is this much. Now if you take L common here, then this L1L cancels with this, so we are left with root 2 times KL over 2 KL minus P. This is your sin alpha by 2. So alpha by 2 is sin inverse of on this. So, or you can say alpha is equal to 2 will come to this side. 2 times sin inverse root 2 KL over 2 KL minus P. So it's a good one. Thank you. Very much. May I request if you may subscribe. If you find the contents are interesting and explanation is good. Wish you a happy Holi 2021. Thank you very much. Thank you.